Welcome, everybody. We are working on Unit 7 this evening, and we are going to start by talking about data types. Um, in the old textbook that we used to use, this is Chapter 8 material. So if you have Murox, MySQL, that's the chapter you want to read. Otherwise, we're going to take a look at reference materials online from two different sources, and I do it as a basis of comparison partially. Data types, in essence, when you start talking about any sort of coding, the type of information that you're dealing with becomes relevant to how you store it and how much space it occupies in storage and what capabilities it has in processing. So, for example, if I store words, it's assumed I'm not going to do math with them, right? Whereas if I store numbers, I have that capability, right? And this is an important concept. Also, if I take a number and store it a certain way, it'll occupy a certain amount of memory space, where if I store a word, it will occupy a different amount of memory space. So, and to kind of explain this, um, really we should go back and talk about binary bits and bytes. And so this is really kind of silly, but I'm going to just kind of, right, I'm just going to do this. And I think this is kind of interesting, when you look at what's a bit and what's a byte. And um, we talk about memory and storage and all this stuff, and we do it without really necessarily understanding what we're dealing with. But we do know that computers speak binary at their core. So in other words, when I'm working on a computer, the information that moves around internally is all electronic pulses. And electronic pulses, we assume they're ones and zeros, but in reality, the way that it works is it's positive and negative voltages. And so a positive voltage spike is represents a one, and a negative voltage spike represents a zero, right? And then you take a series of those, ones and zeros, and put them together to form information. Now, the interesting thing about bits and bytes, right, is, and I'm going to bring up what I call the ASCII table. And I hope this is a good site. I'm just going to click on it randomly without knowing. And they talk about, for example, that every time, and what an ASCII chart is, if you guys are curious, is every time we press a key on the keyboard, and I'll get to a spot on the keyboard that makes sense, like letters and numbers, for example, and I press a key on a keyboard, every time I press a key on a keyboard, it generates 8 electronic pulses in binary format. And what you see here, this column here with the ones and the zeros. So when I press the capital letter A on my keyboard, it puts out this binary sequence of zeros and ones. That's the electronic positive and negative voltages that are going through the system to generate that character. To us, it means nothing. To the computer, it goes, oh, this is a capital A. This is what the computer goes, oh, capital A. Right. Now think about this as you're typing like 1,000 words a minute or whatever your typing capability is. Um, you're generating that many pulses, right? And then if you type something and you save it, then it gets stored in memory. So the point is that electronic pulse, if I'm storing the letter A on the computer, is stored as that sequence of characters. Now it also represents a numeric value in the binary number system, which is 65. So this is the number 65 in binary, right? The computer knows this and deals with it with no problems. But if I was to generate in binary the number 1, I would just need one character, the number 1, right? So there's only zeros and ones in binary. What key sequence would I need for the number 2? Well, if I exhaust all my digits, 0 and 1, then it goes to 1, 0, right? So the number 2 is 1, 0. That occupies 2 digits. So I can do the numbers 0 and 1 with 1 electronic pulse. I can do the number 2 with 2 electronic pulses, and also the number 3. I get to the number 4. Now I need 3 electronic pulses. So what I'm showing you is that when I have letters always will occupy a certain amount of space. And then I can just say, well, how many letters do I need? and I multiply that basically by 8. And by the way, each one of these characters is a bit. You put 8 of them together and it's a byte, right? And then if you put 1,024 of those together, it's a kilobyte, and 1,024 kilobytes together and it's a megabyte, and 1,024 megabytes and it's a gigabyte, and on we go, right? That's the scale of multiplying. But it's based on the base 2 number system, and we look at groups of 8s, and they're all powers of 2 basically. But as I store larger and larger numbers require more and more bits to represent them, so they store a lot differently than data does. When you use a programming language like Python, right, and most of us will learn that first these days, it doesn't care what the data type is, it just deals with it, right, silently in the background. But then you learn a language like Java or SQL, and it's very particular about the data type, because of the storage considerations that go with it. And more importantly, and I'm going to say more importantly, but equally as important, the processing that happens if I try to do math with numbers versus if I'm trying to concatenate strings, right? Both you use addition signs for both of those things. All right. So the way the information stores is part of the reason why we have data types in the first place. And that's my grand little speech to lead us there. All right. Over my Brave browser somewhere here, I am on the W3 Schools MySQL reference page here, looking at the entry on data types. Now, it is important to note, and I think I've mentioned this before, that MySQL has gone through various versions. The current production stable version is version 8. It's the one that we're working with when we did our install. And if you're working on the Prometheus server, which some of you guys do, that's the same version we're running there. There's sub numbers that go with it. It's like 8 point something something. But the first number in a version number is always the major version number. The previous major version production number that people were using prior to 8 was 5 for MySQL, which is kind of weird. So they kind of had like weird, we'll call them beta builds. So like version 6 and 7, which didn't catch on or for whatever reason were unstable. And then they put out version 8, which is a stable version, so people build stuff on it, right? And that's not unusual in software. All right, data types as a general rule, and we've looked at these very briefly before, for SQL databases basically fall into, I'm going to call it 3 broad categories, and there's some other like new ones that are, I don't know if those form new categories or if they're just subtypes. But the general categories are strings, which is text, right? Or characters is really a better way to look at it, because that can include letters and symbols and numbers as text, including emojis, by the way, which is a new thing that's kind of out there too. They've now, I think, standardized several thousand emojis as character text. So they formally are on the ASCII table now. And then we also have numeric data types, and there's subtypes of that. And then we have date and time data types. And then sometimes they'll give us like different categories, but those are the 3 big categories. So strings, which are characters, words, letters, numbers, symbols, numbers, which are just numbers, and those can be integers, floating points, etc. And then we also have date and time and DateTime, right? That's a whole separate grouping. And those we've already learned about, because we had to build some tables and you have to declare data types for databases. All right, so let's dig in and kind of learn more specifically now about all the variants of it, because I think this is pretty interesting. And there's a little bit of history that goes with this too, because when we started doing like string data types, for example, this was the only one that was out there, and you would have to, well, it wasn't the only one of the few that was out there. And that's what we used in the old days and pretty much all database systems. And here's a really big part of it that I'm going to highlight. It's fixed, right? So for example, what that means is if I have a character field and I declare it to be 20 characters long, and then I type 3 letters into it and save it, it's still storing 20 characters, right? And in old database design, we almost always use fixed on purpose, for a number of different reasons. First of all, when the computer was processing it in the background, it had a consistent size data set it was processing for each character field, right? And, granted, a lot of it was empty, but whatever. It was consistent in size. So the memory allocation was consistent. Of course, if you're not utilizing all the positions, you're wasting storage space. So you could fill up a hard drive and it could be mostly empty. This is really a weird thought, right? So, hey, all that stuff and it's mostly empty. Well, think about the comparison I would have is like if you print stuff on a piece of paper and you try to fill up the piece of paper typing words, well, there's still spaces, there's margins, spaces between paragraphs, indents, you know what I mean? So there's space wasted on the paper too. If I wanted to use a piece of paper efficiently, I would type the characters as close as I could together, all the way to the margins, top to bottom, you know what I mean? But then it becomes hard to read. So sort of similar with the database. Characters these days is still used, right? But when you use it, the size is required. And so, like, for example, if I was going to do middle initial for a database table, I might use character and I might cap it at how many characters. And does anybody want to guess? How many characters would I use for a middle initial? Right, Finley, that's exactly the correct answer that should pop in your head. It's like, well, my middle initial starts with the letter G, so I just need one character for that. Well, but if you were a person that was using let's say a form on a website and you ask for your middle name, you may or may not fill it out, right? Or you may intuitively, because we do this when we type the letter and a period after it, right? Well, that's two characters. And then, not to be weird, but what if you were somebody that had, well, I'll just give you an example. I know a few people that have like several middle names, not just one, right? Like Francis, Joseph, Matthew, whatever, right? I have a few friends like that have like multiple middle names because every one of their grandparents want to be included or something, right? And then how do you deal with that? Right. And it's like, no, I signed my name with my first name, my 5 initials. Right. So you got to think about that really carefully. Right. So I would say that if I was doing a middle initial, I'd probably do 2, but I might do 3 or 4 just in case somebody's one of those people. Right. And there are those people. And sometimes they're very proud of it on top of it. Right. So think about the character size very carefully. And like, for example, if you decided to store a phone number as characters, which is actually, generally speaking, a better practice than storing it as numbers, you cannot predict, will the person type parentheses around the area code, or will they put dashes or periods in between the blocks of numbers, or God forbid they're from a different country and their phone numbers are only 6 digits long, plus a area code, plus a country code. You know what I mean? So you got to like think of like what the maximum situation might be, which may or may not apply to a situation, right? So these are all things that you think about. If you don't declare a size, the default is 1, and sometimes that's adequate. Another spot where you might use that one is a 2-letter abbreviation for a state, right? So that's really common also. The one that we tend to use more often for characters and probably the default go-to is varchar, right? And that's how most of us in the industry say it, which is a variant of character. It is variable length. Okay, so here's the advantage of variable length. If I type my name in and I set the size to 20, but my name's 5 characters long, the other 15 storage spots are released back to the system to use for something else. Way more efficient, right? So most database programmers, even for like a fixed length piece of data, might choose to go varchar just for that reason. Because if I did middle initial, and let's say I set it to 5, right? Somebody doesn't put it in, well, the 5 character spots go back to memory, right? So that's a reason. All right. So these two, very common. The one that we use most often is this one. And I would challenge you to think about how much space do you really need for something, right? How long is a first name? How long is the last name? How long is an address? How long is a comment from a comment form on a website. Well, that could be really long, right? But you think about what that is. And when it says here that the size can be from zero, I don't know why you would set it to zero, but from 0 to 65,535, that's how many individual characters, including spaces, special symbols, emojis. An emoji, by the way, operates in one space. So you have to think about that, right? So if you have a situation where your people are feeding information that exceeds that, it won't work. It won't get stored. If you guys ever received maybe a piece of mail or something, this doesn't happen that much anymore, but in the old days it would happen all the time. If you had a really long name and you get something that was like mail merged from a database, sometimes your last name is cut off because that it didn't fit in the database. That kind of weird thing. All right. So let's look at these other two here, binary and var binary. And it says equal to character, but stores binary byte strings. Okay. So in other words, it's already converted to ones and zeros, right? And that's really kind of the main thing. So like, what situations would you want to store straight up binary information? Usually as the result of a calculation that was done in a binary format, right? So that's out there. I'm going to say rarely used except for by weird computer scientist people, right? The next one I'm going to go to is we're going out of sequence now. Is I'm going to look at text, right? And I want you to notice the difference between text and character. This looks at up to 65,000 individual characters. This letter is a character. This space is a character, right? Text, on the other hand, is based on bytes, meaning 65,535 times 8, right, for the bits in there. So this is a storage capacity, right? But does it really vary from varchar? I want you to think about that. If you do the math on it, you'll see where I'm leading you to it. So otherwise, basically what we're looking at is an amount of storage. This, in many cases, can also be used interchangeably with varchar. And some people do that, kind of an older standard, new standard, right? And if I was to suggest, I would go with the new standard pretty much always. All right. So since we have text, we also have tiny text, medium text, and long text. And those are all related. And I want you to notice the difference here. If this is text, and then we go to tiny text, this only holds 255 characters, right? When we go to medium, 16 million, almost 17 million characters. That's pretty large. So I could like take a paper like that's many pages long and dump it into that field, right? And that happens. Databases do hold things that are that large. And then we have a long text, which is 4.2 billion characters, right? So like, I don't know if that would fit a novel, but it might get close, something like that. We also have the blob, and this is once again for binary things, dealing in ones and zeros. This is like way nerdy stuff, right? It's like computer scientists and whatever would use this. And they have a standard size version. Notice same memory usage. They have a tiny, a medium, and a long for that as well, right? And it's all about storage. Now, if you're not picking up the correlation here, basically, that this is kind of the standard storage size, and then you can have smaller and larger versions as well to use memory more efficiently if you know you need it. There's a couple of others that they throw in here, and these are related to what we call data structures. And data structures are ways that we organize data together into a grouping. So for example, if you go to a website and you fill out a form, and I just did this today because I went to the conference. I thought I was registered, by the way. Thought I did it a few months ago, but apparently it didn't stick or something. So I had to re-register at the conference. Not a big deal, but you're filling out these fields and drop downs and check boxes and yada yada. Hit submit, and I get to one box, and this is like demographic stuff, and it's like you have to declare your age, your race, your gender, that kind of stuff. And for example, like gender, male, female, other, prefer not to say, whatever, whatever category you box you check, fine. um but there's a fixed number of choices, including prefer not to say, right? And what you would do in an enumeration is to have preset values for something, and that gender selection would be an excellent uh, um, example of that, right? Because you know I don't know, like maybe, if I was an alien, there'd be like 54 genders. I don't know. You know what I mean? Or no gender. But for humans, they've come up with these like 4 or 5 categories they put us into, and you select one and it's got to be on that list. So basically, an enumeration, an enum is short for enumeration. It's an enumerated list of values that you select from. You can't select any others, just those. And then when you do it, right? So, like, for example, this might say male, female, other, prefer not to say, alien, something like that, right? However many values you need. And then that's used basically like when you select one of those, it just selects from that list and puts it in the database as one of those. And usually as a representation of one of those in a referencing standpoint. Sets are similar. Um, and this is kind of interesting though. Okay, 0 or more values, I'm not really sure why you would do that. But it also, like the enumeration, gives you a list of values that are predefined, but it does have a difference, and the difference is the size, right? So this can store, once again, that magic number of 65K, right, versus just 64. And if you think about it, this is probably appropriate for most things like what I just described. If there's only 5 possibilities, why would I use an enumeration? It takes us way more memory. I don't need it. I would probably use a set. I think as a go-to, because the memory is usually dynamically allocated, people tend to go for enums because they're used to that from regular programming. Right. Let's move on to numbers. All right. With numeric data types, once again, we have a whole list of them here, and I'm not going to follow them down in order of how they're listed. I'm going to go through them in the order of what is logical to me in terms of how they're structured and their functionality, and then show you that some of these have basically multiple values like the string ones did. So the first one I'm going to look at is one that we've already used, and that would be integer, right? And notice you can declare a size on this as well. An integer, once again, just to remind you what that is, that's a counting number. 1, 2, 3, 4, 5, etc. Right? 3.25 would not be. That's a floating point number. Okay, and that's got a different data type. So with an integer data type, and then I just want you to notice that you can say integer all the way, or you can just say int, right? And most coders are used to doing it like this, and some will do it like that, whatever. We use this one a lot because it's very, very useful for a lot of different things. And notice that an integer can hold values, right? It doesn't tell you what its limitations are. It tells you how big a number you can store. If you're using a positive value, you can go up to this, which is 4.2 billion, right? The power. And then otherwise, you can go from here to here, negative 2 billion to positive 2 billion. So it can take negative numbers as well, right? If you have numbers that exceed that range, then you go to the larger version, which is the big int, and you'll notice how that is a way larger capacity, right? Or if you don't need that much, you go to small int, smaller capacity, and then there's a tiny int, which is even less, right? And then you also have a bit, but all the ints are interrelated. So tiny, small, medium, big, int, and integer. Well, I guess there's a medium too. Sorry, I skipped over it. So there's like 7 or 8, but they're all integers. Okay. Do programmers who build databases ever use anything other than int? Okay, real frankly, in the modern era where the convention has become, okay, memory management's dynamic. Now I don't worry about it. I just use int, put in the size I kind of want, right? And I want you to notice that the size parameter specifies the maximum display width. It may not show the whole value, right? So when you do get a value that's kind of like up in these ranges, it'll display as exponential notation. So it'll be like 4.294 times 10 to the whatever power, right? To represent the number of zeros. That's how systems will do it. So the size declares how much you can see, not how much it stores. Very different from the text ones. The text ones are how much it stores and how much you can see, all of it, basically. Numbers don't work that way. It's inefficient, basically, because when you are dealing with numbers in this scale, it does become more efficient mathematically to scale it with exponential notation, right? And if you guys don't know what that is, that's where we just say this number is the same as, let's say 4.29, whatever this is, times 10 to the whatever power. And how I would figure that out is I would count 3, 6, 9. It would be 4.294, whatever, times 10 to the ninth power, right? 9 zeros, right? Is how many decimal places we're moving. All right. A couple of other weird ones in here. So they have Boolean, right? And I want you to notice these are both related. 0 in Boolean is false. Non-zero values, not one, anything that's not a zero is considered true. So we don't store true or false. Why? Because true takes 4 characters and false takes 5. 0 is 1 character, and any other thing you throw in there is true. All right, much more efficient, right? So there are situations where we generate large data sets that are just simply true and false values. You know, are you driving the car? No. Are you driving the car? Yes. Is it true or false? You know, it's one or the other. And a lot of data is more efficiently represented that way. So this is an important one too. I would say that not, you know, you don't see the use for doing this over and over again, really. But for example, when you have a lot of data that you're collecting, and maybe you just want to have a checkbox for customers, like existing customer, yes. You know, I don't need more than that. Right? Just a true false makes a lot of sense. All right, let's move on to the floating point numbers. And we have a few different types here, and these will mimic really closely what I see in what I'll call traditional programming languages, such as Java or C# or any of those types of languages where you have to declare data types. They will have multiple floating point numbers. So any of you guys that are web students, if you've taken the Java Programming 1 class, you get to the part where you start learning about, okay, hey, an integer, a string, you know, you get those pretty quickly. And then you discover it has a lot of the same stuff that are in the database, right? And then you start to learn about floating point numbers, and basically floating point numbers are numbers that have a number, a decimal point, and some numbers after it, right? So I can take the number 1 as a floating point number. It would be 1.0, right? And it is important, even if there's no value after the decimal point, that a number is a floating point or not, because if you know those traditional languages, if you multiply an integer against a floating point number or do division or something like that, when you mix data types, the thing happens called casting, right? Because if I just do straight up math with integers and it doesn't give me any decimal output, it might be because, not because there isn't any, it's because that numeric format doesn't support it, right? So if I multiply, 1 times 2, okay, well, that's 2. But if I divide 2 into 3, well, now I have a floating point number. But if I did it with integers, the answer would be 1, right? Because 2 goes in there once. Well, you didn't, it's not floating point. So I can't tell you what the remainder is or the fractional portion after the decimal point. Now, some of this stuff, and I want you to notice here, like float, and this is a way way old way we used to do it, that's deprecated. And whenever you see this word in code, deprecated means it'll still work, but they really prefer that you don't use it. This command is basically dead. right? If the syntax is completely removed, it just won't work. Deprecated means it'll still work. It may not work how you want though, so that's always the other caution. So something is deprecated, you usually want to switch. So this one, let's take that one off the table, right? Don't use that one. We also have just regular floating point numbers, and then this is kind of interesting because this one adds what they call a p-value, and it says to figure out whether to use float or double for the resulting data type. So when you use the float data type, really what it's doing is it's converting to double if it needs to. And then I want you to say a normal size, or C, a normal size floating point number is a double. And most of us who are writing database stuff will either use double or decimal as our data types for numbers that require decimal points. Okay, so the way that we do it, the total number of digits is specified in size. So if I'm storing a 20-digit number to the left of the floating point, right, that's what we're talking about. And then the D parameter is how many digits after the decimal point. So I can declare on both sides. I need 10 decimal points on the left side and 10 decimal points on the other side. Now, if we do money, right, what would we set it to? Well, hopefully the left side's like trillions, right? Yeah, not happening for most of us. And then if we're doing money, what's after? What's the D going to be? It's going to be 2, right? Because we only need 2 characters, at least for American money, right? So these are things that you think about. So if you need a certain level of precision, so for example, if I was storing batting averages for baseball, I would need 3 digits after the decimal point. And how many digits would I need before? Well, 0 technically, but right, because the percentage, well, you would need 1 because it's possible somebody might have a perfect batting record for a day. All right, so double is one. Here's the difference though. There's also a decimal data type, which I'm going to argue is a little more precise in some ways. And notice that it says an exact fixed point number, right? All right, and this has a normal size floating point number. Now, the implication with a floating point number is this. If I did some math and I came up with, let's say, I do some division with floating point numbers and my answer is a whole number, like 2. In storage, it would store as 2.0, right? Now, an exact fixed point number, the way that it conversely operates is whether or not I have something of value after the decimal point, it will store exactly those amount of digits after the decimal point. Where if I did a double and I have 0 there, I mean, it's storing the 0, but it doesn't store anything else because it doesn't need to, because it's empty, right? Where a decimal would store that 0. That's really the difference. And so in some ways, it's sort of better for calculations if you use it as a root for the calculation. And it's got the same parameters. So to the left of the decimal point, to the right of the decimal point in sizes, basically. And it says the number of digits after the decimal point is specified. The maximum size is 65. Notice that this one doesn't really indicate that. Okay, interesting. And then the maximum is 30, right? And the default value for size is 10, and the default value for D is 0. So if you don't declare them, it goes with 10 and 0 here. Okay, why? Because you didn't declare it, so we're not going to create it, right? And really, maybe you should be using an integer instead. All right, so those are the numeric types. What we'll typically see with floating point numbers is you pick one or the other, depending on what you're doing, right? People who are purists very often will always use decimal for financial amounts, always, right? And then there's others that are like, no, double's better, because of the dynamic memory. If you get the same value, it doesn't really matter. But I would maybe agree with the purists on the money thing. But if you're doing any other kind of calculation where you don't know how many decimal places it's going to be, go with the double is the safe way to say it. Or if you know that like a baseball average is always going to be like, point and then three numbers, then you could maybe go with this, right? Because you know that's going to be a fixed amount that you're looking at. All right. We'll talk about these date and time things. This should go pretty quick. And we're going to look at oddball, and then we're going to take a break. I know we've been going for a while. Now, we've played a little bit with this, right? And I think I've explained these before generally. We've talked about the fact that date format store year, month, day. That's how they store numerically. And you'll notice that it has a range. And I think this is kind of interesting that it can store dates from the year 1000 up until the year 9999. Why? I'm not really sure. And I'm not sure why they would exclude dates from earlier. But, let's be frank here. We probably don't have data from the year 1000. So, like, we're like, looking at stuff, you would probably do some other calculation to determine date. Now, really funny, and this is kind of a totally a sideline, by the way. When computers were first sold to the public, does anybody know what the lowest date or like the earliest date you could set your computer for? This is some weird computer stuff. If you're an old person like me, you just know the answer to this. Right. Well, the answer, if you're curious, is 1970 for whatever reason. It's like, well, there weren't really any real computers before then, especially for consumers. So let's just like the earliest date you can set your computer to is 1970, right? And believe it or not, in the old days, we would leverage this, right? So like if you had a piece of software that was trialware and it would expire in 30 days, one hack was you just set your system clock back and then it doesn't expire. Not good for all the other stuff you're doing, but hey, that's the thing. All right. We've talked about the date format. We've talked before about the date time format, where it also includes hours, minutes, seconds in this format, right? And it shows you the range. You can also do a timestamp, and this just like, for example, you create a new record in the database. This is a common usage, and then you just have a timestamp. When was the record created? Oh, there it is. Okay. Right. Or when did that order happen? Like when you go to a point to sale system, right? You can also just narrow it down and just choose the time. So hours, minutes, seconds. And you can just choose the year, right? And I want you to notice this one. That's kind of like what I was talking about with the old computers, right? The dates that are allowed when you use just the year thing are 1901 to 2155. Very interesting. I wonder if 2556 is the apocalypse. I'm not really sure. Right. And then you can also put in zeros, right? And notice MySQL 8 does not support year in 2-digit format. And by the way, if you guys have ever heard about this thing, and maybe you haven't, but when I first started in IT and I was, had my first job in the, early to mid 90s, and we were encroaching upon the year 2000, and we were working with a lot of database systems that stored dates with 2-digit formats. Why? Because it saved memory. Isn't that ridiculous, right? They didn't want to, and then we had this whole Y2K or year 2000. Yeah, there you go, Finley, scare, which, and this is a real thing, right? So like a lot of systems were at risk, right? Because, hey, we're going to flip. And then all of a sudden, what year is it, And there was plenty of work for people in the years leading up to the year 2000 and some after, fixing databases that had this problem. Yeah. You know what? And you know what? And I was not nearly that young at that point in time, but that was a real thing. Fortunately, the world didn't melt down, right? We're still here, obviously. All right. So those are the data types that we have here. And you know what? I'm going to switch now over to the other link that I have, and I'm just going to copy that link address and I'm going to paste it here into Brave so it can go relatively ad-free. This MySQL tutorial site is basically going to reiterate all the same information we just looked at. So I'm not going to go through all of it, but there's a couple of things included in here that were not included on the W3 Schools page, by the way. So I'm going to take a look at those here. Oops, sorry. There we go. On this site. So once again, here they have a kind of like a quick list. And what I like about this, and this is actually kind of cool. And in fact, you know what? That might be a nice little graphic to drop right into our core shells with the copyright, right? To be respectful, right? Since we're borrowing it. So I'm gonna make sure that I do that later, but I'll add that to our core shell. So that's like a quick list of what I'm going to call the ones that we tend to use most often, right? Um, so I think this is a pretty good, concise list, right? So data type and the specs on each, and it's 2 columns of it. All right. Once again, they go through all the numeric data types. Right? We talked about all those. Talked about the Boolean thing. Talked about the string data types. So they did numbers first and then strings. Then they do date time. And then they have these. Okay, so here's some new stuff that's kind of been added. And these are what we call spatial data types. And these are related to coordinates and geometry and graphical information systems and things like that. And dealing with plot pointing in 3D space and 2D space and all that kind of stuff. So these are used. So for example, when a Google car drives down the street for Google Maps and they're mapping everything and they're relating it to GPS data, they're capturing all of these data points. And so it's also related to a GPS point. So this is what we use often to store like GPS data, basically. So these are custom designed data points for doing that kind of stuff. There's also a new type out there, which is a JSON data type. And JSON, if you guys are not familiar, and I'm just going to quickly Google it here. JSON is what we call JavaScript object notation. I'm just trying to find like an image of some JSON here that's kind of clear. And I'm not going to like totally dig into this. I just want to show you what it looks like. But it's basically data that's structured in what we call key value pairs. That's inside of curly brackets, semicolons, and colons, right? And if you did the Python class or if you studied JavaScript, the syntax will look familiar. But basically, JSON is a really common data transmission format for websites, databases, apps, for whatever reason. And part of it is because, like, for example, here this word name would be the equivalent of the table column or data field, right? And then Richard is the value that's stored with it. And then we put in a separator. Richard's age is 33. Here's his hobbies. Notice this is a list. This would be an enumeration, by the way. And it goes on. And then here's another, this might be a set of data for a list of friends. So this is like JSON within JSON. But you notice what's cool about JSON is that the data is contained and it also shows you what data it's attributed to. Now, no data types are associated here, which is one of the problems that regular databases had. This is a collection of data, but this data can feed a database or can be stored from an application, very often from a web application as a data transmission format. So they developed that data type specifically for holding JSON objects because they are that kind of pervasive now in application building. And JSON, once again, stands for JavaScript Object Notation. And in most programming languages, we'll call this an associative array or key value pairs, or in Python, we call it a dictionary, right? If you had your Python class already, it's just a different type of data structure. Very much all the same, by the way. And that's why JSON is so popular, is because it plugs in beautifully to PHP and JavaScript and pick a language, Python, C#, Java, whatever. And since databases are often storing this information from our applications, it makes sense for them to be able to work with it natively and not alter it, right? Not have to convert it somehow. So that's the reason it exists. The other piece of information, and this, I promise, this is the last piece of information in the lecture, is I have this link that also takes us to the same MySQL tutorial site. So I'm going to just take us directly there. And they have kind of a quick overview of the whole language here on this page, right? And they talk about the different basics, right? And if you guys look at all these commands that they have here and how we've kind of covered a lot of this stuff, right, already, believe it or not. Some things we're still learning. But if you go to section 11, which is what I'm pointing you to, you'll notice at the very bottom here that they talk about all the data types we talked about, and they're showing up JSON as the data type. And yes, JSON is what it is. So it's expected that you're going to put that in. And then they also have this other one that's kind of, we'll call it sort of new, which may become the replacement for primary keys in databases. And some people doing modern application building and database design are already using it. So they call it the UUID, right? So that's kind of a thing, right? So I just want to put it on your radar so you know. So if you go for a job interview and they say, hey, you ever worked with UUID in MySQL? You can go, well, I've heard of it. At least I kind of know what it is, right? It's a replacement for primary keys. And that might be enough to open up the door for you to step through. All right, folks, let's go ahead and take a break. When we come back, we'll work on the exercises. Let's take a little bit longer break because I've been talking here for a while. We'll come back at 7, so about a 7-minute break. So I'll see you then.